Hi, welcome to Wall Chart Wednesday. Today we're going to talk about DC motors and controls. I'd like to show you our diagnostic chart, which encompasses DC motors and problems within them. If you notice, the title is DC motors and controls. One of the studies that we did several years ago was about a 3-year study on DC motors and controls alone. And that showed that 62% of the problems within DC motors were actually caused by the controls rather than the DC motors themselves. So let's take a look at the diagnostic chart and take a look at, first off, a normal spectrum. If you notice, we have a running speed, 1 times RPM, 2 times running speed, as you would in any machine. And then you have a frequency which is going to be in all DC motors, called the SAR frequency, right? And for the US and countries that have 60 hertz electricity, the SAR frequency will be 6 times 60 hertz, 360 hertz, which is 21,600 CPM. For Europe and South America and other countries that have 50 hertz line frequency, the SAR frequency in fact will be 300 hertz, which is 18,000 CPM. Now, when this is a normal looking spectrum, when you have problems with broken armature windings, grounding problems, or faulty system tuning, then the SAR firing frequency goes up tremendously. It may go up from on the order of 0.02 inch per second to over 0.1 to 0.12 inch per second peak. And also accompanying that is 1 times line frequency that goes along with the SAR frequency. If moving on to the next thing, now we'll move on into the controls. First, we looked at just the motor itself, the armature windings, etc. Now I'll move it into the firing card. If you have problems with the firing card, you look at your SAR firing frequency. Very low in amplitude, normal amplitude, maybe 0.02 inch per second, 0.03 inch per second. What's involved here, these 2 peaks are not supposed to be there. That's 1/3 times the SAR and 2/3 times the SAR frequency. So for a full wave rectified DC motor, that would be twice line frequency and 4 times line frequency, remembering that for a full wave rectified DC motor, SAR frequency would be 6 times line frequency. Then you move on to problems with the faulty SCRs and shorted control cards. Here, this is a great surprise to those of us who studied DC motors for 3 years. We all thought that if the problems occurred with the SCRs, that the SAR frequency would lift quite a bit in amplitude, but in reality, it remains practically the same. What happens is that a whole series of frequencies appear that are not supposed to be there. That is 1 times line, 2 times, 3 times, 4 times, 5 times line frequency. And in particular, the highest frequencies are 1 times line frequency and 5 times line frequency. And finally, the other problem that occurs often within DC motors are faulty comparator cards, which control the speed of the DC motor. These are, again, part of the control mechanisms that keep the speed constant, keep it from hunting. If you notice these little sidebands, which are blue in color, to the right and left of SAR frequency, these are not 1 times RPM sideband frequencies, but they're the difference in RPM. For example, if your DC motor is supposed to be going 1200 RPM, and it's actually hunting 1200 up to 1240 CPM, then back down to 1200, back up to 1240 CPM, that difference frequency is 40 CPM. So to the right and to the left of the SAR frequency would be not 1 times RPM sidebands, but the difference frequency of, in this case, 40 CPM. Thank you so much for your listening, and we'll look forward to our next installment of Wall Chart Wednesday. Thank you.